All right, good afternoon, calculus student today. So just want to talk about that 2.1. So section 2.1 from James Stewart Calculus. So this one is the tangent and the velocity problem. So find the average rate of change. So anytime they see that the key phrase average rate of change, so that means you want to find the slope. Okay, so the way to find the slope, we do know that it's delta y over delta x. So m is the slope. Or this one can be written as y2 minus y1 over x2 minus x1. Okay, so the slope formula. So for this one, the function we have is y equals x squared, the little caret. That means the power sign. So what we got is f of 4. Okay, so another way you can express that is f of x2 minus f of x1 over x2 minus x1. So f of 4 minus f of 2, and then divided by the quantity of 4 minus 2. So f of 4, so 4 squared, then that would be considered 16. And then 2 squared, that's 4. 4 minus 2, that's 2. So 16 minus 4, that's 12 over 2, then that would be 6. So the average rate of change for that from 2 to 4, it's 6. And then for the rest of this, pretty much we want to do the exact same thing. F of 3 minus f of 2 over 3 minus 2, then that would be considered 1. So again, it's always the setup first, and then after that, you want to simplify it, evaluate. So f of 3, so 3 squared is 9, minus 4, so that's 5. So as you can see that the slope is getting smaller. And now this one is getting very close to 2, so from 2 to 2.1. So f of 2.1 minus f of 2. So 2.1 minus 2. And then f of 2.1, not quite sure what that is. You can always use a calculator. Okay, going back to normal screen. 2.1 quantity square. Or you just multiplied it out. 4.4.1. Okay, so 4.4.1 minus 4 over 0.1. So we do have 0.41. Divided by 0.1, so that'd be 4.1. And now, the purpose that we're doing all the average rate of change, so we just want to find out that the, not just the rate of change, but we want to compare the slope. So we can estimate the slope at 2. So the slope here at 2. So as you can see that, so from 2 to 4, so 4 is all the way up here. So that would be like a secant line going through. And then the slope here, that's just like a tangent line. Okay, so the slope, let me just redraw the line here. So we do have a secant line and a tangent line. Okay, this time I want to use a solid line. So from 2 to 4. Okay, let's just resketch that, the graph. Hard to see that. Undo. So let's say we do have a secant, the secant line, and then the other one is the tangent line. So the tangent line, I want to use the dotted one. Okay, let's just put in different color for that. Blue. Okay, so the tangent one. Well, I try to zoom it in. Those two lines, eventually they're parallel. So what they're saying that, so the tangent line and the secant line, if they're parallel, so that means the slope got to be exactly the same. So in order to estimate the instantaneous rate of change, so the only thing that's different here, instantaneous rate of change, so that means it's finding the slope at that point. But the average is finding the slope in between 2 points. Okay, so try to estimate it. So the 1 is getting close to that slope here at 2. That would be considered 4.1. So eventually that's about what? 4. Okay, try to round it up. So eventually the slope is about 4 unit. Or we can say that if that's like a meter per second, that would be meter per second, but there's no units, so just leave it like that. Okay, so now let's take a look at that. The other one, so the other one, it's given with the point. So 1, comma, 1 over 2. So this one, that line's on the functions, y equals x over 1 plus x. So this one, we can use a graphing calculator for this. So we do know that point Q, it's a point on xy, so use a calculator to find the slope of the secant line PQ for the following value. So just find the slope of each positions, 1.1, 1.01, and 1.001. As you can see that this one is just like getting the approximation of the slope at 1. So first thing that you want to do, you want to put in the functions, rational, x over 1 plus x. Okay, so let's just clear all this. Clear. So we got x over the quantity 1 plus x. So once you come up with the rational function, and now you want to put in the point. So the initial point, it's 1 comma 1 half. Okay, so 1 comma 1 half. So for y2 here, so I want to put in that 1 half, the y value, because that's a constant. So let's say 0.5. And now for y3, you want to put in the slope. Okay, so the slope, again, according to the formula, it's y of f of x2 minus f of x1. So the way that you want to put in the slope is like this. So you want to go to vars, y vars, and then function, and then press y1. So this one, we don't know what that is, so it's just y1 of x. Okay, perhaps you might want to put in the parentheses because we want to put in the whole quantity. Okay, so let's start this one over again. So this one, open parentheses, vars, y vars, function, y1. And then parentheses, x, close parentheses, minus, again, y2 is considered 0.5 because that is just the initial position for the y value. So let's put in y2 or just put in 0.5. Okay? And now you want to divide it by the quantity of, so open parentheses, x minus. So for the initial x value, we just consider 1. Okay, so minus 1. Okay, so now what I would like to do here, I would like to go to XY table. So in order to go to the table, you want to go to second, graph. So again, the given value we have here, it's 1.1, 1.01, 1.001. So now let's just find out the slope at each position. So 1.1. So for the y3 column, so the slope is 0.2381. Okay, so that slope here, 0.2381. And now what about the slope at 1.01 to 1? Okay, now let's find out what that is. Calculator, 1.01. And the slope from 1.01 to 1, that's 0.24876. So 0.24876. And now, what about the slope at 1.001? It's getting very close to 1. Okay, so again, back to the calculator. So this time, put in 1.001, 3 decimal places. And as you can see that here, so the slope, it's 0.24988. Now, for those you might be wondering, for y1, y2, we don't need to use those columns, because y1 just give you the y value once you plug in 1.001. The only thing that we need to focus on is the slope, the 4th column. Okay, so now the slope compared to the previous one is getting more accurate because that is getting close to 1. So it's 0.24988. So estimate the value of the slope of the tangent line to the curve at 1, 1/2. So that means we're using that 0.24. If we try to round it up, eventually it's going to be considered 0.25, but I just want to keep the decimal, just want to make sure that it's more accurate. So we'll say that it's 0.249. Okay? So using the slope from part B, find the equation of a tangent line to, well, this one's supposed to be space, to the curve at point B, 1, 1/2. So one thing that we notice, back to Algebra 1, so anytime they want to write the equation of a line, it's always considered the point slope form. Okay, so the point slope form. So basically we just want to plug in everything. So y minus y1, so y minus 1/2, and then the slope that we just estimate, 0.2499, and then times the quantity of x minus 1. And for those you might be wondering, do I need to convert it to the slope-intercept form? You may do so. Basically just multiplied it out and then just add 1/2. Okay, so now let's see what else that we got for the last one. So this one, the table is given already, and we want to find the average velocity for each time period. And for those you might be wondering, do I need to generate the linear regression model? Well, this one, we're not quite sure whether that's linear or exponential. It's not being specified, so there's no need to generate the regression model. So again, using that, the structure, the way to find the slope, f of x2 minus f of x1 over x2 minus x1. So we can find out the slope, the average velocity, and also we can use that to approximate the instantaneous velocity at t equals 3. Again, average, that means the velocity between 2 points, or 2 position. And then instantaneous, that means the slope at 1 point. Okay, so that's the big difference here. So again, if you do have a graph, so the one that I drew earlier, that was the parabola. So let's say we do have a random curve. So let's say that you want to find a slope in between this 2 point. Okay, so let's see. Again, I need the tangent line here. And the secant line goes first, so that's the average rate of change. Now, in between this 2 point, so let's say that we do have a point somewhere getting close to the other point. So let's say that we do have a number right in the middle of those 2 points, or point right here. If you try to make a line segment or tangent line here, so what do you guys notice? So it looks like those 2 lines, they're parallel. If they're parallel, that means the average rate of change is the same as the instantaneous rate of change. So back to the concept of geometry or algebra 1, if the slope of 2 lines are exactly the same. So what does that imply? That means the lines are parallel. So now let's use the table to find out the slope for each one of those. So the first one is showing that f of 3. So according to the table, is time versus distance. So we do have f of 3 minus f of 1 over 3 minus 1. So this one's for I. So f of 3, we do have 10.7. And then f of 1, which is 1.4. And then 3 minus 1, which is 2. And then you want to calculate that, the slope here. So 10.7 minus 1.4, we do have 9.3 divided by 2. So using the calculator or just convert it to fractions, it's up to you. You can do it either way. So 9.3 divided by 2 Not quite sure what that is. Always show the word. So that'd be what? 4.65. So that shows what? Meter per second for the unit. And then for the rest of those, you want to do the same thing. Find out the slope. So again, the one I really want to find out is the one right between 3 and 4. Because that is getting closer to the instantaneous rate of change at 3. Okay, so now let's find out the one from 3 to 4. This one is pretty much the same thing, 3 to 5. The same process. So f of 4 minus f of 3 over 1, because the time difference from 3 to 4 is 1. So f4, so the distance is considered 17.7. And then f3, it's 10.7. Subtract, so we do have 7. Oh, this went down the bottom, that's 1. So 7 over 1, so which mean is what? 7 meter per second. And then estimate the instantaneous velocity when t equals 3. So that's about 7 meter per second. Again, so the slope here is getting closer and closer to 3. So that means eventually the tangent line is the same as the secant line. So eventually the slope or the instantaneous velocity, it's what? 7 meter per second. Alright, that's it. Thank you for watching the video today. So I'll see you guys next time.